Hello everyone. In this video we're going to be doing the solution to the quiz number 2. So at the first point we have to find the two angles measures in radians between 0 and 2 pi such that sine of t is the square root of 3 over 2. So of course there are multiple ways of doing this, but we are going to take the unit circle, and when we take the unit circle we're gonna look for a particular value of y. Since sine of t is y in the unit circle, we're going for a line of height so that this is square root of 3 over 2, right? So this is the square root of 3 over 2 in height. So that's gonna give me two different angles. That's going to give me this angle here, and that's going to produce also this angle here. Those are the two different angles that I can obtain. One of them is going to be here, and the other one is going to be here. So if I locate the first one, then I can barely easy find the second one. And so I can use this triangle that is forming here, and I'm gonna get information from that triangle. I do have some information on the size of that triangle that I can use. So for example, since this is the unit circle, I know that the hypotenuse is gonna be 1. And I know that this side is going to be square root of 3 over 2, right? So I also know that this is going to be then 1/2, just by doing the fact that I can complete 1 square is equals the square root of 3 over 2 square plus x square. So when I solve for x square, I find that this is 1/2. So this point here that I'm looking, it corresponds to the angle 1/2 square root of 3 over 2. And so because of that, this point over here is going to correspond to square root of 3 over 2 as well in y, and in x is going to be minus 1/2, since it's just going to be a reflex of this. So if we talk about what point on the unit circle is going to give me this point, then you can easily find out that, let's say, theta 1, which is this small one, is going to be 60 degrees, or you can also think of it as pi over 3, since we're being asked of it in radians. Also, theta 2, which is the angle on the second quadrant, is going to be the 120 degrees, which corresponds in radians to 2 pi over 3. Notice that noticing that this is 60 degrees is not bad, and this is 100 degrees is bad, but the answer is expected in radians, since this is what I'm asking you. So to have full points, you should have your result in radians. Now let's go to point number 2. We have that assume that certain washing machine wobbles back and forth according to the following model. So W2.56 sine of pi over 5t, where W represents the number of inches the machine moves to the right or left as it wobbles. So it's going left, right, left, right, left, right, and that's the bouncing movement that it does. So remember that bouncing movement is going to be the sinusoidal function that we have over here. And of course, this amplitude is going to represent how much it moves to the right and to the left. So when we're talking about the period, remember, we look for what this wave speed is, and the period is given by 2 pi over b, if we're considering this a sine of bt. Okay? So that means that this is 2 pi over 5, and so if I put a 1 here, and I cross multiply here, so top with top, bottom with bottom, I get 10 pi over pi, and this is going to be 10. And of course, this is going to be t in seconds, right? Since the units are seconds. Now it says, how far to the right does the machine move at the greatest displacement? So because this is talking about greatest displacement, we're talking about amplitude. So you can see clearly that this is 0.56 and is inches. So this is 0.56 inches, and that comes from the amplitude over here. Be careful not to confuse this with the phase shift, because there's no phase shift in this function. Now, point 3. In point 3, you have a couple of questions, but only one of them is necessary, the other one is optional. So in number 3, we have that an object starts at the point A, and in this diagram, it travels twice around the circle counterclockwise direction, so it goes in this direction. Assume that the object takes 12 seconds to travel around the circle twice, and it travels at constant speed. The radius of the circle is 3. So initially, we want to know what are the coordinates of the object at t equals 0. Notice that t equals 0 is the starting point, which is A. So to give the coordinates of this, so A is going to be given by 3 cosine of 2 pi over 3, 3 sine of 2 pi over 3. Since this is what we get in terms of Cartesian coordinates. Of course, then this is going to be 3 times minus 1/2, and then 3 times the square root of 3 over 2, which are the values for cosine of 2 pi over 3, sine of 2 pi over 3. Now, the last question, the bonus questions ask, well, at what values of t, the interval between 0 and 6 is the object at the point 0, 3. So if you think about it, what is 0, 3? 0, 3 is this point here, where I'm reaching pi half, right? So this is the pi half. So I want to know how much it takes me to get back there. Notice that because this takes 12 seconds to travel around the circle twice, it only takes 6 seconds to move on the circle once. So it goes from here to here in 6 seconds. So that means that it covers 2 pi in 6 seconds, right? So this means that every seconds, this is moving pi over 3. Pi over 3 radians per second. So if it moves pi over 3 radians per second, well, we clearly can see that it's going to take 3 seconds to get here to the other side, 4, and probably to get here in this point is going to be pi over 3. So if you do 5 seconds, at 5 seconds it will be where? Starts at 2 pi over 3, so 5 seconds more is moving to pi over 3 per second, means that it's going to be a 7 pi over 3. But 7 pi over 3, what is it? 7 pi over 3 is just 6 pi over 3, which is 2 pi, right? Plus 1 pi over 3 more. So this means that 5 seconds later will be where? It will be 5 pi over 3, which is the movement per second, plus the initial position, 2 pi over 3, and this means 7 pi over 3. But if we go back to considering that we're in the same circle, 7 pi over 3 is just really 6 pi over 3 plus pi over 3. And this is 2 pi plus pi over 3. So essentially, we consider the position that we are in the unit circle at the start. And I'm talking about in terms of equivalent angles. Of course, this is not the same quantity, right? So we're going to be back here at pi over 3. So we want to know, so to know how much it will take, well, it turns out that to get from pi over 3 to pi half, I can do pi half minus pi over 3, and so this is like pi over 6. But pi over 6 is what in terms of pi over 3? Well, is like 1/2 pi over 3. And so since this is moving this much radians per second, this movement here, pi over 6, means like half a second. So this means half second more. And so we have 5 seconds to get here to pi over 3, and we need half a second more to reach here. So at the end result is going to be 5.5 seconds. And so that is the solutions for quiz number 2.